Cool. I think that worked. That worked. Yeah, it worked. All right. So this is the Sig-auth meeting for Wednesday, April 14th, 2021, and we have a big agenda this time. So let's get started. Let's see, Gauntlet Wizard. Is that you, Ted? Don't know who
That is me, yes.
You want to do a demo for us?
Yes, I would like to do a demo.
Um,
I will share my screen.
Okay. All right. So I made you a co-host because that's the only way I know how to do this.
Yes. All right, thank you. I'm taking over. Just share my desktop. All right. So what I'd like to demo for you today is called Kuba Tls. It is a add-on to your Kubernetes cluster that automatically appends TLS certificates to each pod. So the objective here is to make MTLS easy by auto-mounting in exactly the same way the service account token is auto-mounted a TLS certificate that is signed by a certificate authority common to the cluster. So I will start off by showing off like the cool bit of the demo, which is I've got a pod here that is my greeter server. It's just a copy of the Golang gRPC example with some enhancements made to actually use MTLS. So I will port forward from it. Oh shoot, what is the actual port that's on? $5,551. Right. Cool. If I go to this web page, we can look at the certificate that it is using. And this certificate is named with the name of the service account that this pod is running as. It is generated with some DNS names that correspond to the pod's name as well as the matching services. And this is all automatic. I did not specify this in the deployment spec. It is added by a mutating webhook controller. Let me know if I'm going too fast here. I'm assuming that everybody is already pretty familiar with how MTLS works, pretty familiar with how mutating webhook controllers work, deployments work, etc. I don't want to take up too much of the time. So doing that, it generates a certificate. Here is the contents of that certificate. I've put it at a well-known certificate location that more or less matches where service account tokens go. This particular server is actually configured to use MTLS. So if I proceed to localhost, I actually get back the bad client auth cert. It does not let me even fully establish the SSL connection because I have not presented a good client certificate. On the other hand, my client application, I just create a job that runs the client application. And this will work just fine as soon as it, actually creates there we go. So this launches, this figures out its TLS certificate. It has a mutual TLS certificate that is trusted by the application because it is generated from the same certificate authority that it trusts. And it all is pretty just magical. So I come to you today to demonstrate this and to talk about it because this no longer works in 1.9 or 1.22 when certs v1 goes away. because the certificate authority that it's using is the Kubernetes certificate authority. And it is just assuming that we can approve and issue things, that the Kubernetes cluster itself will issue certificates. You know, my fallback plan is to generate my own certificate authority and issue certificates myself, and that's certainly a thing that Kuba Tls can do.
Correct me if I'm wrong, but certificates v1 should still be present in 122. It's just the v1 beta 1 API that's going away.
Sorry, v1 beta
the
1.
legacy signer,
Yes.
it sounds like.
It's the
Okay.
legacy signer that is going
Yeah.
away. So I actually have 3 different proposals that I would like to talk about. Mostly just to get a feel for the room of which of these should I push for. So I didn't see this pod specific dual cert. Oh man. Huh. This is pretty much exactly what I'm looking for. So there's somebody else.
This sounds a lot like the resolution of this issue. I think there are a lot of situations in cluster where something like this would be useful. For example, metric scrapers, the kubelet ports are kind of like an unsolved problem as far as authentication. Other things, setting up PKI for admission webhooks and aggregated API servers is very challenging today. So I'm kind of all for having some support for built-in dual serving certs. So very cool demo. Not related to the problem that you are facing with 121, which I'm happy to dig into as well.
I mean, the 122 is simply that legacy is deprecated, right? The v1 beta 1 is deprecated, and so I need to start generating my own certs rather than like the existing signers don't solve my problem. So the Kps that I was going to that I'm working on are basically just adding signers that would be appropriate for Kuba Tls to use. So where do I have? I've actually got 3 different versions of this, so excuse me while I talk about them. One of them just is a generic MTLS. It will sign anything that is a valid MTLS. This is broad scoped, and so I can see lots of cluster administrators not wanting to support this, right? They want to disable this because if the cluster CA is used to sign something, then I don't know, it's got permissions from the cluster CA. It could impersonate a node. Version 2 of this involves a bunch of specific signers. So a signer for a user, right? Once upon a time, I had all of my users set up with client certificates generated in exactly this format, right? I called out manually to approve client certificates, client CSRs. And then I gave everybody their client certificates. I wrote some little scripting that would automate all of that on their side so that I never had to generate them keys. A key was automatically generated. I went back to my computer and hit approve, and then their client program watched for the thing and just installed it, which is great. We'd also create a service account, which is exactly, creating a signed certificate for each service account, and then a service, which would be used for TLS server certificates, must be server auth.
So
Yeah, I think
how are you distributing trust?
Distributing trust is that the nodes themselves are trusted. And when when the node creates a pod, when it admits a pod, it generates the key, it creates the CSR, and the signer checks that the right node has the CSR, and that it matches the pod that it is theoretically requesting for.
No, I mean the CA bundle that
Yeah,
verifies.
for MTLS things, like the CA bundle has to be on the receiving end. And so plumbing
And it-
that around.
And it
has
already
been-
is. It's in the service account CA bundle.
No, that is actually the misunderstanding that the V1 Beta 1 API propagated. So the thing that is distributed in the service account token is only the signer for the Kube API server
Okay.
certificate,
Not even a
nothing
signer.
else.
It's not even
And so
the-
assuming that that bundle is valid for all of these things, or that the same bundle contains the CAs for all of these things,
Right.
is
Okay.
not a great assumption. So the trust distribution is actually probably the hardest bit of this. I like the idea of being able to have a service account certificate or a service certificate. I like that idea, but the trust distribution is definitely the long pole.
Trust distribution can be very simple. It can be mounted in a well-known location, in the same area where you're mounting the TLS certificate, right? If you're distributing a key to each application, you can distribute a CA to each application. It only works intra-cluster, but if you trust something to mount into your container namespace, then you trust it as the source of truth.
So to clarify, if you create the certificate, the certificate private key for the pod that it can use for MTLS, you can also then put in all of the certificates in the certificate chain up to the CA certificate for that.
Right. Well, you really only need the one certificate.
Yeah, or you could have the certificate with all this the other stuff bundled in, but either way, but you can provide that information via the mount.
Right. I think the key bit that we would need to figure out is how do consumers indicate that they want the CA root for these particular uses, and that we don't smush all of the CAs for different uses together. Because like the CA for signing service account credentials might have very different expectations than the one that signs services, or the Kube API server serving certificate. And so having consumers be able to express somehow that they want a CA for this use, whether it's looking in a well-known location or indicating it somehow like that, I think that is probably the biggest unknown.
Right. And this goes to, wherever this gets mounted, it should be whatever is mounting the pod's private key and certificate should also mount with the CA bundle in that same location.
I think I would expect pods or consumers to explicitly indicate they wanted this, rather than like auto mounting 4 more.
Absolutely.
Yeah.
But this would be from a perspective of this would be either a cluster add-on or a cluster feature that the service account tokens also get a service account certificate.
Service account tokens are actually going away. Like we're moving in a direction that says we aren't going to create and we are not going to automatically mount tokens for service accounts. I think it's even on the agenda today.
Yes, it is.
Okay. So
what replaces that as a, like the feature of Kubernetes automatically distributing an identity or trust to your application is actually very useful. You've still got that with the OIDC provider, but I mean, is that the solution? Is that the replacement for automount service account token?
We could probably talk about this as part of the next discussion item. I know Mo was trying to time box this.
Yep.
From the pod's perspective, the token is not going away. The mechanism for delivering the token is changing from mounting a secret, which would be something that an add-on could sort of glom additional keys into and piggyback on, which is not recommended or supported.
Yeah, 100%.
To like a purpose built, like we inject this token. And so, yeah, I wouldn't see this being part of the service account token. This is a different thing. Like I need to receive trust roots for this purpose. So figuring out what that mechanism is the trick.
Okay. I don't see the service account token. I completely agree that like the secret for the service account token is a misfeature. I would like to see the ability to use MTLS for that service account token as a replacement for that service account token, that you should be able to call the Kubernetes master using an MTLS certificate rather than a token, because a token is a shared object, whereas an MTLS certificate is unshared.
So we're doing a little bit of thought about this.
Yeah.
We're doing something a little bit related to this.
Okay.
And one thing that we've done that you may want to consider, or that we may bring to Sig-auth in a month, in months, would be a CSI driver for doing this. That could be injected via like an annotation or something.
I would be very interested in helping with that. Fundamentally, what I want is a mount with, it needs to be, from practical stake, it needs to be a mount of some sort. It needs to be on the file system that you have your TLS certificate, your CA bundle, and a key that is provided before the application even starts up.
Definitely.
But what we're really trying to do is to make this easier for developers to do encryption, right? Right now, John developer can't encrypt because trying to figure out where to get your TLS keys from and everything is just the biggest pain in the cahoot. So if we can provide,
Yeah.
Sorry. I was like, I don't think we want to have a Discord chat on the screen.
yeah.
Yep.
So, but we just want to make it
one question.
easier for Johnny Dev to encrypt. Go ahead, to here.
Why have a separate signer type for services? Why not have services just present their service account as the principal?
So that was actually my third application, which I didn't get to, which was we should just create, like, there should be a cluster pod certificate authority and a cluster pod certificate type where every pod within the cluster, use one CA root, automatically gets a MTLS cert that says, I am this pod running as this service account. Because quite frankly, I like Sig-auth, right? I miss Sig-auth. Few of you will get that.
Yeah.
But and we see this as pretty much at kind of a cluster level, a cluster option, rather than at an individual pod or an individual service level kind of option. And the reason is that once you start doing MTLS, you should buy into that. You buy the TLS across all of your services. And so if we give you certificates to do that, you should, they should be available where sort of across the cluster. And same way with MTLS, you should have both service and client certificates available everywhere. So we see this more at the cluster level rather than at a namespace or a pod level, individual object. Just turn it on for the cluster. And yeah, everybody gets a thing and they may or may not use it, but in most cases, they really should.
I'm going to time box this for right now. I think there's vague agreement of we can do a thing. So I think you can write a KEP and we can go review said KEP and we'll fight over there, or we can continue discussion next time. I just want to be able to get to everyone else on the agenda.
We can spill over to Slack, the Sig-auth channel.
Yeah, or send the 3 KEP template or prototypes like out to the mailing list. Kind of like those.
All right. Let's see. Tim, are you on the call? Did you want to talk about PSP real quick?
Sure. I don't think I have a whole lot to say here other than go take a look at the KEP if you haven't already. There's still a handful of unresolved sections open, but we're making good progress on those. And I'd like to at least get the provisional KEP merged in the next week or so, and try and get the last few unresolved sections closed out soon after that, so that we can start implementation for 122. Any questions about that?
Is there any blockers?
Just closing out those unresolved sections. I'm going to push an update probably later this week that will clearly mark the remaining unresolved sections, whether they're a blocker to this being implemented in alpha or not. We do still need to choose a name before going to alpha. And I think the other unresolved sections are either very close to being resolved or can be punted to post-alpha. We are still doing the bi-weekly discussion of this KEP as a breakout session. So there's another one of those on Wednesday. Those will probably wrap up once the KEP goes to implementable, or we may kind of keep them on to review the implementation itself.
Cool. Thanks for working on that. Mike, did you want to introduce the annual report?
Yeah, I just wanted to announce this. This is, I guess there's an initiative for maybe from the Contrib-X SIG. Actually, I don't know what the origin is, but they have this kind of standard questionnaire where ask questions about Sig-auth. So Rita, Mo, and Tim and I got together, filled it out. I think we had some good discussions on stuff that we could do better. And yeah, so take a look if you're interested. Feel free to offer suggestions, and maybe probably next meeting we'll go through in more detail and brainstorm together.
Cool. So, all right. So let's see. I think the same person has token controller deprecation and the encryption config stuff.
Actually, can I add one more announcement before we move on? I'm not sure if we mentioned this in the last Sig-auth meeting, but Rita will be taking over my responsibilities as chair. So we'll be kind of doing a gradual transition of that over the next month, approximately. I do still plan to be actively involved in the Sig-auth community. Just going to be stepping down from the administrative chair responsibilities. And thank you, Rita, for volunteering to step up there.
Whoa. I'll clap for that.
I'll do it too. That's good. Awesome. All right. Chihong, did you want to start?
Yeah. We can start with the encryption config one. So we've seen scalability issue related to the secrets. When a cluster has a large number of secrets, they're gonna make a huge number of calls to Cloud KMS, right? KMS providers in general. And so we propose that maybe we can extend the encryption config to have a variable, basically, which means let's say if this value equals to 100, basically it's 100 secrets share the same DAC to reduce the cost to Kms provider. So yeah, just try to looking for opinions on this. There's one issue with this is how to deal with the rotation after sharing the DAC. There are two possible ways. The first one, the one that I prefer personally, is to extend the encrypt call to return a key identifier from the KMS provider. And we use the KMS health check to notify us there's a key version change. The second one is more transparently we need to figure out a way, like a mechanism to re-encrypt the secrets. So you can imagine there are three events in a key rotation. The first one is the user initiate a key rotation or key version rotation on the KMS provider, and then they do the re-encrypt, right? And then the KMS plugin does the actual things. So the first two events, so the first event is the user initiate that key rotation, and then between the first event and the second one, they can use the second mechanism here to notify the Kuba server to do to basically refresh the DAC, or we do it like after the first event, right? After the first event, right after the first event that they do the key version rotation on the KMS provider, and then we know it from the health check right away. It's like a couple seconds per health check.
So I wanted to ask. Oh, sorry. Go ahead. If I thought you were going. Sorry.
So basically, the config itself, without the health check changes, it's back compatible because the current one is just basically it's one, right? Basically every secret use the single DAC. But for this change, it could be, it's not a back compatible because we need to extend the encrypt call, right? Yeah, I was just trying to look for opinions on this change.
So I wanted to ask,
like,
as a starting point, if I understand correctly, though, the specific scalability concern that this is trying to address, you could address that with a local KMS to the API server, right? That delegates to the cloud KMS, but only every 100 keys or whatever, right? Like it generates a key, asks the cloud KMS to encrypt that, but holds it in memory and does the encryption locally, right? So just.
Okay, you mean do the caching in the KMS plugin?
Yeah, like if the
He's describing hierarchical checks.
Yeah, like a hierarchy of your KMS, right? But one would be local, so it doesn't have any real overhead because you're not actually leaving the kernel of the API server machine, right? You're just sitting there locally. And then
So that's one of the alternatives Shihong has analyzed. I can't quite remember what there was something we discovered that was not optimal about that.
Yeah. Yeah. So basically, yeah, hierarchical one will also work, and we probably will not make changes to the open source. But I think there's one talk about the KMS improvements. We also don't have a good observability on secrets, like which secret is encrypted by which key, right? But if we extend the encrypt call, we can get that information, like, right? I think, yeah, this change basically can benefit the community. I think.
Yeah, I think there's two problems. The first one is the scalability issue. It can be addressed outside of Kuba API server in a KMS plugin. That is fine and reasonable, but does it make sense to solve this inside Kuba API server to solve the scalability problem in a way that I guess applies to more implementations of KMS plugins? And I think the second thing is,
as a quick thing on that, my expectation was that that daisy chain of the KMS could be a completely open source Sig-auth subproject, right? Because then you get to have more flexibility, right? Like you can have whatever configuration you want at that layer, and it doesn't have to go through like 5 layers of API review.
yeah, that's a good suggestion as well. It's a middle ground.
Yeah, I wasn't sure if any of the rotation bits required what got persisted and then returned for decryption to change. That was the only thing I couldn't tell.
Yeah, that's the second problem, which
Yeah.
is we need a storage version migrator for encrypted objects, basically.
I mean, does the storage version migrator not do this? I guess it doesn't know when it needs to do it, maybe?
But it
Exactly.
can be told via an API object. You create an API object and say, hey, rotate, and it will go off and do it.
So I remember the doc you're referring to, Shihong. That one, I think one of the suggestions had been there that we could try to migrate the actual on-disk format on KMS to like a proper, like well-known encryption on disk format. So that way we could, even if it's not like a REST API or a thing that you probe outside of the API server, if you could actually read the encrypted encrypted values out of etcd, you could actually understand at like a provider level, like what the state of the world is, right? Like I was kind of hoping for something like that, mostly because it doesn't overcomplicate the API server and it lets you kind of do arbitrary logic on the outside for whatever you want. And I also kind of hoped for like, even if we end up in a state where we want to have the API server do more work and sort of be a little more intelligent, I was really hoping that that logic would live in the actual gRPC API. So like, instead of the encryption config getting a new knob, the API server would ask the gRPC plugin itself, like, hey, what do you want me to do? And it would tell it, right? And my hope there was that we push more intelligence and more requirements on the backend piece, because that's the piece that actually knows what the security constraints are, right? Like it knows what keys it's using and for what reason, right? Like if you set that number to really high, depending on what kind of encryption you're doing, it's actually not safe. And maybe it doesn't matter because the number has to be ludicrously high, but let's just assume the user doesn't know how to configure this thing. It'd be nice if whatever Vault KMS plugin was there, it knew what it was doing based on its knowledge, and it would just tell the API server what the correct config to use it in was, instead of like this like weird coordination you do between these sort of unbounded components.
Yeah, thank you for your inputs. I think because the current implementation in open source for secrets or config maps, because they both use the encryption config, right? Rely on the third-party KMS provider. I just think it's not scalable by its design currently. For example, it's not a it's like a surreal encryption cost to Cloud KMS, right? Definitely we can do it in the backend and have more customized logic there. And also for the I think probably for the observability, right? currently we don't know which secret is encrypted by which key. What do you think? Ignore the knob here. How about do we need to like extend the encrypt call to return that information so that we can have the observability in the open source?
So I don't know how these APIs, like the gRPC style APIs, how they fit into the Kubernetes API semantics. Like, could we add a new function? Like, is that valid? Does that work? That
A new function will work, but yeah, I just don't know whether it's reasonable or not. Currently there are two, right? Encrypt, decrypt, and a version function, I think. Yeah, it's a service that is shared by the Kuba server and the Kms plugin, I think.
When we were exploring this, one thing that seemed like it would clearly need changes in the API server was having an explicit way for users of this subsystem to request a full rekey. Right now in our setup, we kind of have them do that with a dummy annotation that they can like change, and then that ends up introducing like a decrypt encrypt cycle for all secrets. But the KMS plugin implementation actually doesn't really understand that these encrypt decrypt requests arose because the user wanted to rotate their keys.
So having done rotation before, why don't, like in the actual encryption config and behind the API server, why don't you just re-add the KMS again as a higher item in the list and tell it to do re-encryption that way? Like, because the API server will see it as a completely different KMS and encrypt it, right? It will start saying that all data is stale.
The problem is observability. It's impossible to know when it's done. Or yeah.
I mean, you run a storage migration, right? After you have like you add the new KMS as the last item, you wait for your API service to roll out. You put the KMS at the top of the new KMS at the top of the list. You wait for that to roll out. You run storage migration. You wait for it to complete.
Mechanically, it works, but you can't verify. Like, there's no way to infer that it worked. Basically, observability.
I mean, it being opaque to the API was
by design
inherent in the storage transformer design. So this is like, if we want to revisit that, that's fine. But the fact that it's not observable via the API is working as intended.
Also,
Sure.
it is sort of observable, right? Because if you run a storage migration and like the resource version of like the returned resource version doesn't change, the API server is saying it's not stale and it doesn't need to do it right. That's how you observe it.
How does the storage version migrator actually work?
It does a get put and with the exact bytes that it got, and if what would be stored to etcd is the same, then it's a no op, and if what would be stored to etcd is different, then it does a write, and the resource version increments.
How does it know when to run?
So right now, the only thing that triggers it are changes in the storage version that the API server publishes in discovery, or like something external that pokes a given resource and says, like, I want to do a migration of this resource.
It's sort of supposed to be driven by the thing that's managing your storage, because the API server doesn't know, and it's not supposed to know, at least in the existing design.
The things that you could envision are changing the format. So when we went from JSON to protobuf, like 3 years ago, that required a storage migration. When the storage version changes, so when a beta version of something's gone and we're storing an etcd as v1, like it's a good idea to do a migration then. the API server publishes that information in discovery, and the storage migrator can use it. And then this storage transformation, if you reconfigure your transformation either to enable encryption or to change the key that's used for encryption, that should trigger that as well. But that has to be triggered by the thing that changed the configuration.
Right. So I don't know where this is discovered, where this is exposed in discovery, but would it make sense to also expose a key version on resources that are using application level encryption?
It's exposed in discovery as a hash. So it's an opaque hash that just says like, here is a hash of all the things that affect storage. If the transformation config for a given resource got folded into that hash, maybe that'd be okay. I'd have to think about that. That only would include things the API server knows about. So right now, that's like the config that the API server is fed. Something dynamic like a KMS changing which key like future encrypt requests would use wouldn't be visible to the API server today, so it wouldn't be able to pull that information in. But
you
I
can
thought
force that, though, right?
I thought we talked about actually including some of the transformation stuff in the discovery hash, and it was like maybe that would make sense, but do it in a second iteration. So
I don't remember discussing it, but I also don't know how a Kube API server would know. Right, we've had cases where customers will set it up so there's some KMS process. You go out, you make a connection to it, and it has its own key rotation concept. And so the Kube API server has no concept of like, okay, the keys changed, so when they remove one, suddenly the server can't decrypt because they didn't coordinate the storage migration.
Right. Yeah. So I mean, the config that the server is given, that's easy. If you wanted it to incorporate information from some external source, like to be able to say like, if I stored things now for this resource, what would it do? That starts to sound like some way to interrogate the KMS plugin to say like, what's the current key ID or something. But you're right. That still doesn't tell the server when it needs to ask that question to update, and tell the external system like, please don't delete the old key. Like I'm not done using it. So yeah, there's more coordination that needs to happen there. But including more things in the hash doesn't seem bad at first glance. That's actually one of the reasons we made it opaque, so that it wasn't just the storage version. Other things like the format or the transform config could get incorporated.
If we had a way of discovering it, yeah, I don't object there. The thing is, I would say that as a first thought, I would probably want something to drive the creation of please migrate my storage and watch to make sure it's finished, as opposed to trying to update the storage hash and determine that independently. Like one way or another, you have to know whether a storage migration that was started after a particular point in time is finished before you can remove the old keys.
Yeah, you still want some sort of orchestrator that is like marking KMS keys as still in use until all of the migrations on all of the clusters talking to it have finished.
Yeah, and these are scars from bringing that feature over the line in OpenShift to be able to do the, I have to create this key, I have to make sure everything has it, now I got to switch to be a right key, now I have to do a storage migration, now the storage migration is finished, I need to remove the old keys. That dance is important to get right the first time. And it's hard, I wouldn't want to try to do it side effect based on like, I created this storage hash, let me try to find a storage migration request that somebody else made to see if it matches what I expect.
Yeah, just updating the hash. Like, again, I don't know that I don't think I object to updating the hash, but just updating the hash isn't enough. Like, what if the storage migrator wasn't running? Like, something needs to, you need positive affirmation that it ran and completed, and that implies some like higher level system that can talk to KMS and can observe the migrator.
David, on the stuff in OpenShift, right? Like the distinct difference was that the entire like set of keys and everything is known, right? So like you actually know when you're done. Like,
Yeah, that's I guess part of what I'm trying to describe here. Like I think the orchestrator that does this really needs to be aware of what flow it expects, and trying to build a system on top of a storage version hash seems more likely to maybe miss some edges.
yeah, I would agree with that. Do any of y'all happen to know if the actual encryption config is part of this hash? Like just the static file on disk?
It wasn't in our first iteration.
Right.
But it also doesn't help much for online key rotation. So
Let's see. All right. Okay, we only have 10 minutes left. We probably need to table this and do the next item, the token controller deprecation.
Yeah, this one basically, so it's a follow-up item for the balance service count token volume. I think there are two open issues regarding this token controller. One is the Kuba system that we don't need to generate the legacy tokens for the Kuba system. In the service counts under the Kuba system namespace. The second one is basically to purge the existing tokens for the service counts that don't need the legacy tokens. So in the proposal section, basically the first step, basically we propose some well-known annotation or label, basically to annotate the service count or the namespace to say we don't need the secret-based tokens, don't generate them. And so basically we don't we generate by default, right, to align with the existing behaviors. This is not disruptive in my opinion. But the second step, basically, when we make it false by default, basically don't generate so basically we disable the token controller unless the user specified them to be to generate, right? So this is more disruptive, and I couldn't figure out a way to smooth the first one to the second one over the second one. So so if we agree on the 4 steps phases among I think this will spread over like a couple of releases, but that's a general plan from me. But, well, what do you think? Any better ways to make it less disruptive?
Do we have any warning / audit events for when the legacy service account tokens are used? I forget.
I think we need to provide implement some warning mechanism, but we don't have it yet, I think.
We definitely log metrics around them.
Yeah, metrics.
But adding warnings for them would make sense. There are 2 types of secret-based tokens. There are the auto-generated ones, which once the projected tokens go to GA, will no longer be needed to mount into pods. But there are also manually requested ones. So people can request service account tokens to use from outside the cluster, in CI or for other reasons. And so figuring out how to not support those is a much longer process. So I think the first thing we can do is start warning when you use a legacy service account token. The second thing we can do is let specific service accounts or specific namespaces opt into being excluded. Like, we don't want to use secrets. The third thing is probably cleaning up and no longer auto creating secrets for injection into pods. But we have to keep the token controller running for the manually requested token case until we give much more notice about deprecation and warning and allow those uses to switch to the token request API.
Okay, so you suggest that we don't do the purge thing at the same time as the opt out, right?
Not at the same time, no.
Right.
Yeah, like each of those steps is a distinct step, and the point at which we start cleaning things up or no longer allowing people to request tokens by creating an annotated secret. Those are the 2 points where we have to have a much clearer picture of usage and give much more notice and time. Like I said, if a service account or namespace opts out, like explicitly opts out, I think we have more flexibility there to like clean up that service account or clean up that namespace. But in terms of like automatically doing things on upgrade without someone explicitly opting in, we're much more constrained.
So
Okay.
from a
But we can.
API perspective, how long do we wait?
I mean, the side effect, like being able to create a secret and have it be populated with a token, that probably falls under GA behavior bucket. So that's a year. If someone wants to opt out, like the opt out, I think is what will be helpful for someone who wants to do things like not have super powerful secrets in Kube system. Like if someone's running a cluster and they want to say everything in Kube system that I'm responsible for like has been migrated to projected tokens, like no more token secrets in Kube system. Like they can indicate that on the namespace. And so that gives us more freedom to, clean up things and like, because then it's opt-in. But just for a regular service account and a regular namespace, if you create a secret and annotate it, we should continue populating that token for a long time. We should warn you when you do that, and warn you when you use the token, and like that's fine. We should start doing that. But the types of software that do those things are likely old and have likely been around for a long time and will likely take a long time to resolve. So warn as soon, I agree with the reader, warn as soon as possible. Like we should do that now. But then
I was going to ask, is anyone going to see the warning though? Isn't this like some autonomous CI system that's just doing its thing?
So the metrics can tell you when like legacy service account tokens are being used. So once the default tokens injected into pods transition to projected tokens, and like you have a release or 2 releases or 3 releases, so that all of the pods running on the oldest supported kubelets like have been drained and recreated. Like at that point, usage should basically go to 0, except for anything that was manually created and extracted this way. And so at that point, the metrics would be like a really good sign. Like you've got things using this old path. Generating events is maybe not as helpful as you would think. It's also like doing an API, writing an API object in response to like a request is sort of a scary level of write multiplication. And because events are transient, if you just did it like once when the secret was created, unless someone happened to be watching it right then, it's going to go away in like an hour anyway. So I probably wouldn't write an event. I'd probably warn to the person creating the secret and warn to the person using the token and have the metrics that record usage for an admin.
Yeah, sounds good. I think, yeah, but at this time we can start with the step 1, right? Implement such a notation to opt out. Like in both like a service count level or namespace level, right?
I think both of those levels make sense.
Mm-hmm. And how about we opt out Kuba system at the same time, or in a different step?
That has to be for the cluster deployer to do.
Okay.
We can opt out the service accounts that the controller manager creates. So the service accounts that we create, that we define roles for, that are for use by the controller manager and cloud controller manager, we could opt those out. But we can't opt out all of Kube system. We don't know.
People have a bad habit of running stuff in Kube system that shouldn't be in Kube system.
Yep.
Cool. We are out of time. I know we still have other stuff on the agenda. I will roll that on to next time's agenda and put it at the top so we can get to it.
It looks like a KEP, and so we should just announce that there is a KEP. So review it before the next meeting, and I guess we'll discuss next meeting.
Oh, I didn't know that.
Or if you're talking about mine, it's like a proto KEP, so I need to open the pull request. I'll update the agenda when I do.
The schedule for 122 is not finalized yet. I think they're hoping to finalize that in the next week. But as always, enhancements freeze comes early. So anything you want to be in 122, the designs for those should be getting attention and converging on implementable like in the next week or two.
Cool. All right. Well, thanks everyone for your time, and we'll see you all in 2 weeks.